Good morning. Today we'll solve a problem for synchronous sequential circuit which uses JK flip-flop. So design a synchronous sequential circuit using JK flip-flop to generate the following sequence 7, 4, 8, 3, 9, 2, 10, 1, 11, 0, 7. First what we have to do is we have to draw the state diagram. So already I said how to draw the state diagram previously. So we have numbers more than 7. So what we have to do, since we have number more than 7, it is understood that it is 4-bit. That is, we have to use 4 variables. So 7, starting number is 7, 0, 1, 1, 1, 7. And this 7 is going to the next state 4, 0, 1, 0, 0, 4. Then it is going to the next state 8. That is 1, 0, 0, 0. It is moving to the next state 8. Then the next one is, it is moving to the next state 3. So 0, 0, 1, 1, 3. Then it is moving to the next state, see, 7, 4, 8, 3, 9. So next state for 3 is 9, 1, 0, 0, 1. The next state for 9 is 2. 0, 0, 1, 0. Next state for 2 is 10. 8, 9, 10. Next state for 10 is 1. 0, 0, 0, 1. Next state for 1 is 11. Then 8, 10, 11. Next state for 11 is 0. 0, 0, 0, 0. Then next state for 0 is 7. 0, 7. So this is called as state diagram. So 7, if 7 is present state, next state will be 4. If 4 is present state, next state is 8. Then 3, 9, 2, 10, 1, 11, 0. Again it goes to the first state 7. Now we have to write this in the state table. This is our state diagram. Then we are going to represent this in a table. Now we will represent. So what is the first number is 7. So represent this 0, 1, 1, 1. So this is our first number. Then the next one is 4, 0, 1, 0, 0. Why we are using 4 variables means because here we have 4 numbers, that is 4 states, so that we are, that is, we have 4 numbers, so that we are using this 4 states. Then the next one is 8, 1, 0, 0, 0. Next is 3, 0, 0, 1, 1. Next 9, 1, 0, 0, 1. Then the next one is 2, 0, 0, 1, 0. Next 10, 8, 9, 10. Then the next one is 1, 0, 0, 0, 1. Next one is 11, 8, 10, 11. Then the next one is 0, 0, 0, 0. Because for 0 we have next state as 7. This will move to the next state 7. So this is state diagram. Now we are going to represent this in the table. This is present state. So let us take this as A, B, C, D. These are the present state. Then what will be our next state? Next state will be A plus 1, B plus 1, C plus 1, D plus 1. Now what will be the flip-flop input? Since here they have mentioned to use JK flip-flop. So we have to write the excitation table for the JK flip-flop. This is the excitation table. If our present input is 0 and if our next state is 0, then a JK will be 0x. So this is what you have to remember while solving this sequential circuits. You have to remember this flip-flops excitation table, SR, JK, T, D flip-flop. So write the excitation table. Now what we did is we have written the present state. Now what we have to do? We have to write the next states for this. Now let us write the next states. For 7, see here, for 7 the next state is 4, isn't it? For 7 the next state is 4, 0, 1, 0, 0. For 4 the next state is 8. That is from the 1, 0, 0, 0. For 8, next state is 3. 0, 0, 1, 1. For 3, next state is 9. 1, 0, 0, 1. For 9, it is 2. For 2, it is 10. For 10, it is 1. For 1, it is 11. For 11, it is 0. And for 0, it is 7. So 0, 1, 1, 1. So what we did is, we have written the present state and next state. Now what we have to do? We have to write the JK flip-flop inputs. So how can we write the JK flip-flop inputs? This is JAKA flip-flop. So the present state and next state for this is A flip. So use this. Wait, I'll change the color. Here it is A and here it is A. So while writing JAKA, we must use this AA. Then while writing BB, then we should use this BB. Then while writing C, we must use this CC. While writing D, we must use this D. Here D, here D. So what we have to do is, we have to check this QA plus 1. So if QA, this is QA plus 1. For A flip-flop, let us take QA plus 1. If it is B, QB plus 1. If it is C, QC plus 1. For D, QD plus 1. Now check this 1, 0. For 1, 0, JK is X1. This is for A flip-flop. For 1, 0, JK is X1. Then for 0, 0, check here 0, 0, 0, X. Then for 1, 0, 1. For 0, 1, it is 1, X. Then for 1, 1, for 1, 1, X0. Then for 1, 0, for 1, 0, X1. Then for 0, 0, 0X. 0, 1, 1X. 1, 1, X0. 1, 0, 1, 0, X1. For 0, 1, for 0, 1, 1, X. So we have completed this JAKA. Likewise, now what we have to do is, check this JB, for writing this JBKB, check this QB plus 1. For 1, 0, for 1, 0, it is X1. Let us change the color. This is X1. Then the next one is for 0, 0. QB plus 1. 0, 0, 0X. Then it is 0, 1. 1X. Then the next one is 1, 0. X1. Then the next one is 0, 1. For 0, 1, 1X. Next for 1, 1, X0. Next for 1, 0, X1. For 0, 1, 1X. For 1, 0, X1. For 0, 1, 1X. So like this, we have to complete this table. So what we have to do is, by comparing this QD plus 1, we have written JD-KD flip-flop. Next, by comparing this QC plus 1, we have written JC-KC. Now compare this QB plus 1, write this JB-KB. QA plus 1, write this JAKA from this excitation table. So after filling this table, what we have to do is, we have to find the K-map minimization for this JA, KA, JB, KC, JD, KD. So we have to find the K-map minimization for this 1, 2, 3, 4, 5, 6, 7, 8. So we have to put this 8 variable K-map. Now we have to use 3 variable or 4 variable. We must use this 4 variable because here we have 4 variables. 0, that is this number exceeds 7, because here we have 10, 11, 9, etc. So we have to use 4 variable k map, and now we have to find the k map variable for this A, B, C, D, J, A, K, A, J, B, K, B. So for everything we have to find the k map. Now let us find the k map for this J, A, K, A, J, B, K, B, J, C, K, C, J, D, K, D. So first one is for J, A. Now check here, this is J, A. Here we have Q, A, Q, B, Q, C, Q, D. And we know how to write 0, 0, 0, 1, 1, 1, 1, 0. 0, 0, 1, 1, 1, 0. Now check JA. 0, 1, 1, 1. 0, 1, 1, 1. For 0, 1, 1, 1, 1, 0. This is 1, 1. Then QC, QD is 1. This is C. Oh. 1, 1, 1, 0. So for this our JA will be X. So here we have X. Then here we have, then what we have to do is check here. The numbers are 7, 4, 8, 3, 9, 2, 10, 1, 11, 0, 7. Then the remaining will be filled by X. That is don't care. And here we have JA. JA. For 7 it is X, and we know how to write the numbers here. So write the numbers. Here it is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Then here it is 12, 13, 14, 15. So that it will be easy for us to solve this. Now what we have to do is check this. For 7 it is, we know this is number 7. For 7 JA will be X. For 7 the JA is X. Then the next number is 4. 4, 0. Then the next number is 8. Because in the question we have written the numbers 7, 4, 8, 3. So by using those numbers we can fill this table. Then the unused will be marked as X. Now listen here. This is 7. For 7 it is X. Then for 4 it is 0. For 4 it is 0. Then for 8. For 8 it is 1. Then for 3 it is X. For 3 it is X. Then for 9 X. For 9 it is X. Then for 2 it is 0. For 2 it is 0. Then for 10 it is 1. For 10 it is 1. Here it is 1. Then the next number is 1. For 1 it is X. For 1 X. Then for 11 X. Here we have 11 X. Then for 7 it is 1. For 7 it is for 0. For 0 it is 1. So like this we have to fill this K map. This is for JA. Like this we have to fill JA, KA, JB, KB. Then JC, KC, JD, KD. So that is what we are going to do now. This is JA. And here we have KA. Then here we have JB, KB. And here we have JC, KC, JD, KD. Now let us fill this table. Here we have QA, QB, and here it is QC, QD, because here we have represented as QA, QB, QC, QD. So the same thing we have to write here. So 0, 0, 0, 1, 1, 1, 1, 0. 0, 0, 0, 1, 1, 1, 1, 0. Now check this K, KA. Now check this KA. Is it visible? No. Now check this KA. Now write the numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. After writing this number, what we have to do is KA. First number is 7. For 7 it is 1. Now let us fill this. For 7 it is 1. Then next number is 4. For 4 it is X. Then the next number is 8. For 8 it is X. Then the next number is 3. For 3 it is 0. Then the next number is 9. For 9 it is 1. Next 2. X. Then 10. x 1 0. Then the next one is 11. For 11 it is 1. For 0 it is x. Then the rest we have this left. So fill this as x, 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 x. Like this we have to fill this JA, KA, JB, KB. So like this we have to complete this K map by seeing this table. So this is for JA, KA, JB, KB, JC, KC, JD, KD. Now what we have to do is now form groups and write the answer for this. Let us form the groups. Here we have 1 year, isn't it? Here we have 1. Now pair this 1 1. Let me change this color. Now pair this 1 1 and pair this 1 1. Now write the answer for this group. Here we have QA bar, QB bar. And here it is QB bar. Here it is QA. So AA bar cancel, so that we have QB bar. And here we have QC bar, QD bar. Here it is QC bar, QD. So we have QC bar. Then the next one is, here we have 1. So pair this every one, so that here we have this, everything will get cancelled. Here we have only QD. This is QD. Therefore JA is equal to QD plus QB bar, QC bar. Then the next one, let us move on to KA. Now check here. Here we have 1 1. So combine this pair, and here we have 1 1. So combine this as a group. Now what is the answer for this group and this group? Here everything gets cancelled. So here we have only QC, and here we have only QD. Therefore KA, which is equal to QC plus QD. Then the next one, let us move on to the JB. Now check here. Here we have 1 1 XX, and here we have 1 1 XX. Now combine this to 1 1 XX. Here everything gets cancelled. Here we were 0 1 cancelled. So here we have only QC bar. So JB is equal to QC bar. Then here, check here. Everything we have, this is KB, isn't it? So everywhere we have 1 1 XX, XX, everything. So we can form this as a, oh, here we have 0. So we cannot form like this. Let us form this as 8 group. Now what is the answer for this? If we have X here, then we can combine everything and we'll write this as 1. But here we have 0. So we cannot join a group, as a group. So we can join only this as a group. Now what is the answer for this? Here everything gets cancelled, and here we have 0 1 cancelled. So here we have QA. And here also we have 1 1. So what we have to do is just form this as a group. Now what is the answer for this? So here everything gets cancelled, and here we have QC, QD. So this gets cancelled, QD. Therefore KB is equal to QA plus QD. Then let us move on to the next, that is JC, KC. Here we have JC. Now check here. Here we have only 1 1. So this is enough. If we have X here, we can combine this 4 cells. And now what is the answer for this? QD bar, because this QC, QC bar cancels. That's it. We don't have anything here. Therefore JC is equal to QD bar. And here we have KC. Now check here. Here we have 0. So we cannot combine everything. Here we have only 1 1. And already I said about the minimization of K map, we should not combine only X. Don't care should not be combined alone. Since here we have 1, so we are combining this, and here everything gets cancelled. Here we have 0 0 0 1. The 0 1 cancels, and so this is QB bar. Therefore this is KC, which is equal to QB bar. Then next one, let us move on to the JD. So here we have 1 XX. So let us combine this as 4, and here we have 1 1 1 1. This is JD. Now we can combine this 4, and what can we do is we have this 1 1 and here we have XX. So we can combine this like this. Now what is the answer for this? Here everything gets cancelled. So here we have QB QA bar. And what is the answer for this two? So we have to combine this two and we have to write the answer for this group. So here we have 0 1 cancelled. So here we have QC bar. Likewise here the 0 and 1 cancelled. So here we have QA. Then the last pair here it is 0 1 cancelled. So here we have QC. And check here QB bar. Therefore what is this? JD, which is equal to QC QB bar plus QC bar QA plus QB QA bar. This is our JD. And what is KD? So here we don't have any zeros. So we can combine like this and we can write this as 1. Therefore KD is equal to 1. So we have minimized this by using K-map. Now what we have to do? We have to draw the diagram for this. We have to draw the logic diagram for this. Let me take a paper for drawing the logic diagram. Listen. So how can we draw the diagram for this? This is logic circuit for this expression. So how many flip-flops are there? We have 4 flip-flops, isn't it? We have 4 flip-flops, that is JAKA. Use pen. This is our JAKA flip-flop. And this is our JBKB flip-flop. This is our JCKC. And this is our JDKD flip-flop. Let us take this as 4 flip-flops. So we have clock. Already I said, this is clock. So what we have to do is, since it is synchronous sequential circuit, we'll have same clock pulses. So join this clock pulses here. That's it. So we have given clock pulses for every flip-flop, and let us represent this is A flip-flop. So JA KA. It is JB KB. Here it is JC KC. This is C. And here it is JD KD. So we have represented the flip-flops. And what are the outputs we have? QA or we have QA bar. We will have either QB or QB bar. QC, QC bar. QD, QD bar. Now what we have to do is check in the K-map. So what are the terms available here? We need QB, QB bar, QC bar, QD. So what we have to do is, let us draw the line A bar. Let us draw a line like this. This is QA bar. QA, and here let us take this as QA bar. This is QB. This is QB bar. This QC. This is QC bar. And here QD. Then the last one is QD bar. So let us take this as QA QB. This is QA. This is QA bar. QB QB bar. QC QC bar. QD QD bar. Now what we have to do is, we have to represent this using this diagram. Then here this is QA, QB, because these are the outputs. QC, and here it is QD. Then the next one is, what we have to do is check this diagram. What is JA? QD plus, here we have QD. Check the line where we have QD. This is our QD line. QD. Let us check this QD. Then QB bar, QC bar. Where is QB? Here we have QB. This is QB bar. QB bar line. Then QC bar. This is QC bar line. This is in the multiplication form. So what we have to do is check here. This is JA, QD plus QB bar, QC bar. So we have taken line, this is QD and this is QB bar, this is QB bar, here we have QB bar and here it is QC, this is QC bar. This both are in multiplication. So what we have to do is we have to use AND gate here. This is AND gate. So this performs QB bar, QC bar. Then what we have to do is this is QD is added with this. Now add this. Now add this by using OR gate. And actually this is the input for this JA flip-flop. So this is QD plus QB bar, QC bar. So this is the input for this JK flip-flop. Then KA. What is KA? QC. Now let us take for KA. That is QC. Where we have QC? This is our QC. Then plus QD. Where is QD? This is our QD. Take a line. Use OR gate because here we have KA is equal to QC plus QD. This is QC and this is QD. Use OR gate here because this will become QC plus QD. Now take this to KA flip-flop. That's it. JA, KA is over. Like this, what we have to do is we have to solve for JB, KB, JC, KC, everything. So what is JB here? JB is equal to QC bar. So JB, this is QC bar. So we can give straight line. JB is equal to this is QC bar. Next, what is KB? KB is equal to QA plus QD. KB, QA plus QD. So this is QA. Then this is QD. Take a line. Since it is plus, we must use the OR gate here. Then give this line to KB. That's it. Now what is JC here? So JC is equal to QD bar. So JC is equal to QD bar. Now what we have to do is, here we have QD, isn't it? JC is equal to QD bar. And here we have QD bar. So let us connect this JC . Here it is QC bar, QA bar, QB bar. So I have written, I have left this QB bar, QA bar. So what we have to do is QD bar, QB bar, QA bar for JC. That is QD bar. Take a line from QD bar. Then QB bar. Then QA bar. Since this three are in the multiplication, use this AND gate. And this is our JC. So we are given JC. Now what is KC? KC is equal to QB bar. So JC is equal to QB bar. We can give directly. Here we have QB bar, QB bar. Now what is JD? JD is equal to, here we have three terms. QC, QB bar, QC, then QB bar. This is in the multiplication form. Then the next one is QC bar, QA. QC bar. Let us extend this lines. QC bar. Then QA. This is QA. One more gate. QB, QA. So QB. Where is QB? Here it is. QB. Then QA bar. Here it is QA bar. So this every terms are in the addition form because QC QB bar plus QC bar QA plus QB bar QA. So use a OR gate here. This is our OR gate. So this should be given as input to JD. Then the next one is, what is finally KD is equal to 1. So here we have written KD is equal to 1. So for KD is equal to 1, we can give directly 1. So KD is equal to 1. So this is how we have to draw this diagram. And now here we have QA. Now join this QA. Then join this QA bar. Then QB. You have to join this QA bar to this line. Then QB bar to this line. See, like this we have to join QB. Then QB bar. Then for QC, take this QC line, join here. Then QC bar. Then QD. Then QD bar. Listen, there is no restriction that you have to draw the diagram like this. So this is up to your wish. You can draw like this, or you can draw the diagram like this. You can take here J flip-flop, A flip-flop, B flip-flop, C flip-flop, D flip-flop. Then you can draw the diagram like this also. So if it is JA, what is the answer? Here we have, for JA, we have QD. So we can write QD. So like this also we can draw the diagram. There is no restriction for drawing the diagram. So that is up to you. So this is how we have to solve the problem. That is, this is how we have to design a sequential circuit, synchronous sequential circuit. Since it is J flip-flop, it took more time. If it is T or D flip-flop, we have only TA, TB, TC, TD, DA, DB, DC, DD. So if it is T and D, the problem will be easy. Since if you are using JK or SR flip-flop, it takes time to complete this table, to complete the K map as well as to complete the diagram. I hope you understand this. If you like this, subscribe and share. Thank you.